Hi guys, my name is Peter Petrowski and this is my final project video. The main focus of my video will be on Newton's laws of motion. Newton's laws can be considered one of the most important concepts a student taking General Physics 1 will learn and use. The earlier a student understands the laws, the easier it will be for them to apply them in simple and advanced physics problems that they are likely to encounter. Newton's laws are used from the first day you learn them in the course up until the last day. In this video, I will be explaining what the laws are, some examples of them, and my personal experience with them in this course. Before I begin, here is a little history lesson regarding the laws of motion. Sir Isaac Newton introduced the 3 laws of motion in 1687 in his book entitled Philosophia Naturalis Principia Mathematica. This one volume described the main rules still used in classical mechanics today. Newton's laws of motion help us to understand how objects behave when they are standing still, when they are moving, and when forces are acting upon them. The reason why you are likely to see these laws all through your course is because concepts of motion and forces are applied in almost every problem there is. Now, there are 3 laws of motion that you should know about. Newton's first law of motion states that an object in motion tends to stay in motion unless there's an external force that's acting upon it. Similarly, if the object is at rest, it'll remain at rest unless an unbalanced force acts upon it. Newton's first law is just a restatement of what Galileo had already described, and Newton actually gave credit to Galileo. Newton's first law of motion is also known as the law of inertia. Now, inertia refers to the tendency of all objects to resist any change in motion. In simple terms, the law states that the behavior of objects can be easily predicted. Now, let's go over some examples to better clarify just what the first law of motion is stating. If a ball is sitting on your table, it isn't just going to start rolling or fall off the table unless a force acts upon it to cause it to do so. Moving objects don't change their direction unless a force causes them to move from their path. In terms of day-to-day life, the only one you will see is really just stationary ones, because objects in motion are constantly experiencing outside forces such as friction, making a continuous motion example very unlikely. Now that we've covered Newton's first law of motion, what comes next is the second one. Newton's second law of motion states that when a force acts on an object, it'll cause the object to accelerate. The larger the mass of the object, the greater the force will need to be in order to cause it to accelerate. Now, the law may be written as force equals mass times acceleration, and I'm sure that's an equation that you'll see very often during your studies of General Physics 1. The same way we covered some examples of the first law of motion, let's cover some for the second law to better clarify just what it's saying. For example, a ball rolling down a hill moves faster or accelerates as gravity acts on it in the same direction as the motion. This basically says that acceleration is positive. Now, on the other hand, if a ball is rolled up a hill, the force of gravity acts on it in the opposite direction of the motion. This basically means that the acceleration is negative or the ball is decelerating. Newton's second law can also be shown in some of our daily tasks. For example, a student has 2 identical containers. One is packed with rocks and the other with a few feathers. The student realized that the container filled with feathers was easier to move. Now, this is due to the second law, as mass is indirectly related to acceleration. Our last law is the third one, so let's go over just what it covers. Newton's third law of motion states that for every action, there is an equal and opposite reaction. What this means is that pushing on an object causes that object to push back against you the exact same amount, but in the opposite direction. Let's continue our tradition of showing some examples to better understand these laws of motion. So, to better understand the third law of motion, let's go over the example regarding standing on Earth. When you're standing on the ground, you are pushing down on the Earth with the same magnitude of force that is pushing back up at you. Another way to view this is a frog moving forward and the lily pad moving backward when the frog jumps from it. Now that I've covered what the three laws are, what they analyze, and some examples of them, let's look at the impact and importance of the laws to the physics world. People have actually been using math to predict the movement of planets for many years. All these systems technically worked, however, they made very little sense. Newton's laws of motion were able to explain planetary motion with fewer concepts, and furthermore, those same three laws applied to things on Earth as well. Newton's laws were verified by experiment and observation for over 200 years, and they are excellent approximations at the scales and speeds of everyday life. Now, Newton's laws of motion, together with his law of universal gravitation and the mathematical techniques of calculus, provided for the first time a unified quantitative explanation for a wide range of physical phenomena. Newton showed that the human brain was capable of understanding deep properties of the natural world. Newton's laws laid the groundwork for later theories, many of which fixed certain aspects of the laws that didn't apply in certain cases. Newton's laws are inappropriate for use in certain circumstances, most notably at very small scales, very high speeds, or very strong gravitational fields. Now, although the laws may have some flaws, they can predict the motion and interactions of objects well enough to do some amazing things. So let's list a few. Newton's laws helped us build and navigate spaceships. And to highlight, Newton's laws are the reason that we were able to get to the moon. Newton's laws can also simulate car crashes. They can also measure the mass of the Earth and other solar system bodies. They can explain how airplanes generate lift and even improve your athletic abilities. It seems as though I've covered all aspects of Newton's laws of motion. Therefore, it is the perfect time for me to share my personal experiences with them. The first in-depth introduction to the laws I received was back in my high school physics class. As I mentioned before, the earlier you understand the laws, the easier physics will be to understand in general. Meeting the laws again in General Physics 1 with the amazing Professor David Jacome provided me with the chance to delve deeper than I had before and truly memorize them like they're my favorite song. I can attest that each new chapter the course covered built on top of the foundation that the laws laid out. The first law was definitely very used when it came to frictionless motion examples. The second law was greatly covered in the chapters focusing on forces and gravity. Lastly, the third law was essential in having a full grasp of actions and reactions, as well as drawing free body diagrams. Even the most advanced of topics could be simplified down to Newton's three laws, which is what makes them so special. Thank you so much for watching. Good luck in your physics studies, and I hope this video has been helpful in your journey to understanding Newton's three laws of motion.